Hi, my name's Chelsea Mills and I'm presenting Remote Wavelength, a project to understand how to design systems for social connectedness through distributed tabletop gameplay. Tabletop games, like board games and card games, are a fun way to connect with friends and family. For folks who can't get together in person, say because they live far apart or there's an ongoing pandemic, they can play these games remotely. But remote gameplay isn't quite the same experience. There are some challenges, such as the lack of physical objects, which is part of the fun of tabletop games. And there are limitations to the social experience, including difficulties communicating and maintaining awareness of remote players. There have been a few examples of systems that provide a physical, tangible gameplay experience, synchronized over distance. But research in this space is still in its early stages, and none of the examples we've found had been evaluated with groups of more than 2 players. So, we set out to better understand how to design for social connection in tangible tabletop game systems. We asked 3 research questions. 1. How do groups of players use a remote tangible gameplay system to socialize and play a tabletop game together? 2. How does a remote gameplay system with a synchronized, tangible game board impact players' experiences of social connection during remote play? And 3. What considerations are important in the design of a system that connects friends through remote tangible gameplay? We applied a research through design approach to investigate these topics by making a system for remote tabletop games. We took the existing game of Wavelength, a party game for 3 to 12 players, originally designed by Alex Haag, Justin Vickers, and Wolfgang Warsch. We made a system that enabled a remote, tangible version. Wavelength is a clue-giving and guessing game where one player gets a spectrum card that establishes 2 ends of a spectrum. The player also gets a target along that spectrum and must give a clue to help others guess where the target is. So, if the spectrum was dangerous to safe, as seen here, and the target was a bit towards dangerous, the player might say, driving a motorcycle. Here, we see the completed system, Remote Wavelength. It combines a room-wide video conferencing link with a tangible game board for dialing in a guess and keeping score. Each location has its own tangible game board, and they are synchronized. Here, you can see me reach out in one room and change the location of the blue light on the spectrum in the other. Based on existing literature and design research, we created 5 goals to guide the design of Remote Wavelength. These are head-to-hand player representation. This is to support better awareness of remote players, including gestures and interactions with the game board. Another goal was making it tangible. This aligned with prior work on the importance of materiality in board games. We wanted the boards to be automatically synchronized across locations. We also aimed to make the system flexible, so you could restart a turn, change teams, and we considered this when implementing the code and UI. We also wanted to integrate the communication and game space. So, for example, as you see here, the game card was overlaid on top of the player video. Once we had a prototype that aligned with these design goals, we needed to evaluate it. We wanted to understand what happens when people play Remote Wavelength. We arranged a user study for 10 groups of friends, or 37 people in total, to play together over distance. During the study, we first had participants play in person to learn the game and get a sense of co-located play, and then play for a bit longer remotely. Afterwards, we asked them about their overall experience and what helped or hindered their sense of connection during play. Our results provide an overview of what we learned from the user study. We discovered a set of themes around tangibility and its relationship to presence, engagement, and communication. We also noted some of the drawbacks of a tangible game board. In addition, we had notable findings regarding the impact of digital-physical integration, flexible turn-taking, and game performance on social connection. You can read more about all these themes in the paper. Here, I'll give a brief overview of our results on presence, communication, integration, and game performance. We found that tangible components supported player presence. People appreciated being able to reach out and affect the other location, as well as observed remote players creating changes in their local space. During reflection, participants told us things like, affecting something on their side physically, it feels much more connected. However, we also saw that some elements of co-presence were missing. Interaction through touch wasn't available, and we saw it play an important role when celebrating in person. As one participant put it, I wish there was a way to poke the other side. We saw people use the tangible components to communicate. They used the game board to communicate about the game, for example, by moving the dial to discuss their possible guesses. But they also used components to make jokes or simply mess around with each other. Participants did things like move the score tracker up and down, not to keep score, but to get attention from a remote player. We found that digital-physical integration improves player awareness and communication. A few participants reported looking more at the screen to get game info, and then feeling they were more aware of remote players as a result. People also felt that the integration indicated the system was built for remote play, and that increased their trust in the system and streamlined their communication. Another theme that emerged was players linking their game performance and sense of connection. They sometimes perceived their failures as spotlighting disconnection, and attributed poor performance to their remote setting. Interestingly, one group felt this was in part because remotely, they struggled to read the clue giver's facial expressions. Although technically against the rules, they felt this was part of the fun. They thought their performance was better when they had more cues from facial expressions and preferred to play the game that way. Reviewing these results led us to propose several design considerations for tabletop game systems that support social connection over distance. These include considerations for choosing tangible components, applying flexibility, improving the digital experience, creating an integrated remote experience, and helping players cheat. While the full details are in our paper, a few highlights from the design considerations include 1. Choosing tangible components for presence. For example, we see opportunities to explore the use of miniatures or meeples that could act as player avatars in the remote space and help them feel present remotely. This could also tap into what people love about materiality, enabling them to customize a collection of player characters. In addition, we advocate for the integration of gameplay objects, player communication, and the theme of a game. For example, mixing game objects or thematic elements like costumes with the video stream of remote players could give the game a built-for-remote feel. We also recommend that in social games, system designers include options to transmit the emotions of remote players over distance. Even when this is technically against the rules of the game, helping players cheat by reading each other over distance may actually support stronger social connection. Thanks for watching, and please take a look at our paper for more details.